once we start putting a bunch of other terms in the absolute value, it becomes a little bit cumbersome to think about it as distance, trying to figure out how far we are away from what. So we need some algebraic ways of solving equations that have absolute values in them. So we'll develop a little strategy here while we look at this example. The first thing I want to do is isolate the absolute value term. So the thing with the absolute values around it, the thing inside the absolute value expression there, I want that to be the only thing on its side of the equation. For this particular one, right now I have 4 times the absolute value. So I'm going to do the opposite of 4 times and divide by 4. If I do that on the left, I had better also do it on the right. So now I have the absolute value of 3x minus 2 is 8 divided by 4, which is 2. And now the absolute value is the only thing on the left-hand side of the equation. Now that we're here, next thing I'm going to do is I am going to think about distance. Absolute value means distance without regard to direction. So when we say the absolute value equals 2, we might be 2 to the left, which means 3x minus 2, 2 to the left. Or we might be 2 to the right, which would be positive. So I'm actually going to take my absolute value equation and separate it into 2 distinct equations. One where we consider looking to the left a distance, whatever the distance is, and the other where we're looking to the right. So what did we just do? We're going to separate into 2 equations. One positive, one negative, one left, and one right. So this thing that was inside the absolute values here, this 3x minus 2, that didn't change. 3x minus 2, 3x minus 2. The only thing that changed is I have to consider I might be a distance of 2 to the left, which is negative 2, 2 to the right, which is positive 2. Now that we've done that, I have 2 equations. These are just regular standard issue linear equations. I'm going to solve them in the usual way. I guess the good news is that they're pretty much the same equation except for the right-hand side. So I'm going to do the same things. I'm going to add 2. So I have 3x equals 0 and divide by 3. 0 divided by 3 is still 0. And then my other one, well, I'm going to add 2. So now I have 3x is 4. And I'm going to divide by 3. When I get x is 4/3. And there are this particular absolute value equation has 2 solutions, x equals 0 and x equals 4/3. Let's take a look at one more. And if you want to try this, pause the video, see if you can do it on your own, and then start it back up again. So let's see. First thing I want is for the absolute value to be alone on the left-hand side of the equation. So this plus 1 I don't want. So I'm going to subtract 1 both sides. So now my absolute value, maybe we'll have it be the same problem instead of changing it to a different one, is 5. Now my absolute value is the only thing on the left. There's nothing else around. So I'm ready to separate. 7y minus 4 equals negative 5. 7y minus 4 equals positive 5, one to the left, one to the right. Now we just have left to solve both of those. So I'm going to add 4. Negative 5 plus 4 is negative 1. And we'll divide by 7. So I have y equals negative 1/7. It'd be nice if everything came out to whole numbers all the time, but it doesn't do that in life, so it's not going to do that in math class either. Over here, I'm going to add 4, like we did before. 5 plus 4 is 9. Divide by 7. And we have y is 9/7. If it bothers you, you can say it is 1 2/7. But in proper fractions, there's nothing wrong with them in spite of their name. So we get two solutions to this absolute value equation.